In nature, there are certain things that are symmetrical. That is, if you cut them in half, the two halves look exactly the same as each other, look like two halves of a whole. Other items, both natural and man-made, are not symmetrical. Take, for example, this shoe. It is not symmetrical, and no matter how I decide to slice it in half, the two halves would not be the same as each other. The things that do not have any plane of symmetry, that cannot be cut in half to have two halves that are the same as each other, are called chiral, C-H-I-R-A-L. Now, many molecules also have a plane of symmetry, one or more planes of symmetry. Take, for example, this one representing 1,2-dichloromethane. I could cut it in half right like this, right down the middle, or maybe right down the middle here. It is definitely symmetric. But sometimes, particularly when you have a carbon with 4 different groups attached to the center of it, there is no plane of symmetry. That is, it is not symmetric at all. No matter how I decide to slice these things, right down the middle of the red, black, black, the green half and the blue half are not equal. But right down the middle of the green, black, white, the black and the red are not equal. Maybe if I turn it this way. But again, if I decide to slice this thing in half, there is no symmetry. So molecules can also be chiral, and that is the basis of a new type of stereoisomerism based on things that do not have a plane of symmetry. Okay, one of the things about something that's symmetrical, like this apple, is that its mirror image is the same as itself. Things that are unsymmetrical, like this shoe, have mirror images that are not the same as itself. The left shoe is not the same as the right shoe. The same can be said for molecules. Molecules that are symmetric, like this one, have a mirror image molecule that is exactly the same, also called superimposable, upon itself. Molecules that lack symmetry, like this one, also have a mirror image. However, that mirror image is not the same as itself, and no matter how you try to superimpose them, they are not identical.
At this point, I would like to invite you to visit or view a short video from the Khan Academy, Introduction to Chirality. The URL here is at the top of the page. It is also part of the message that is emailed to you and on the Blackboard announcement. On this particular one, they walk through what is chirality and how do you draw it in 2 dimensions, and how to draw chiral molecules, indicate enantiomers, and other terms that will help you prepare for Chem Activity 12A